Right here, an oven, a vacuum oven to be specific, and it needs to be tied to a PLC. There were a couple of stuff that was easily doable. One was the PLC could easily take control through a isolation device, either be it a relay, take control of the SSR, the heating SSR's controls. So that was no brainers. Okay, the second part was the requirement was to detect, instead of using complex thermocouple fed uh, feedback, which would then require programming for each set temperature. So the simple way was to use a transducer to translate the duty cycle of the PID. And interestingly, when you are near the room temperature, the PID won't go into on-off cycles. It will be predominantly on. As it reaches about halfway through, the PID will get into control. You can see here it is going into partial on-off kind of control. So in this mode, that it for the, at least for this application, and you can do this for any oven for that matter, to and any PID controller to detect what is the duration that it meets when it's near the set temperature. It so happens this is pretty much close to about 8 seconds. So that was decided that an 8-second rule would be pretty nice. When you see an off for 8 seconds, which is a true indication of that it has already reached the the set temperature, and it works for any set temperature. This vacuum oven is set for can be set for any temperature from let's say 50 degrees all the way to 300 degrees. It's a vacuum oven. Of course, it has the other function of infusing nitrogen, that is N2, and vacuuming in between, and those are pretty simple things to do. So it was not a big deal. But translating the ramp time and when to count the soak was the tricky part, and here it's solved in a much simpler but most efficient manner. The simple transducer would be enough, 110 or 220. The one I built was a magnetically coupled transducer which could do right up to 100, 220, either tied to the SSR or to the heater itself. SSR's output itself. No big deal. It could have been done.